Hello and welcome back to Math with Mrs. Becker. Today in pre-calculus, we are going to finish up section 3.5 by looking at composition of functions. So another way that you can take two functions and form a new one is to perform what's called the composition. And what that means is that you actually take one function and put it into the other function where the variable was. So for example, if I have f of x is x squared and g of x is x plus 1, if I compose f with g, okay, whatever is mentioned first, and in this case it's an f, that's the outside function. So I'm going to take the f function, and where the variable is, I'm going to fill in the full g function. So what would happen is in the f function, here's the variable, it's x. X becomes x plus 1. Then from there, I would go ahead and write it twice and FOIL it. So the main thing that you realize is that there's two different ways that you can write compositions. You can write them like this or like this. One thing to make sure that you're careful of, this is an open circle. It is not a multiplication sign, okay? So you would read this f composed with g. It is the same thing as this. Whatever one is mentioned first, that is the outside function. So you are going to take that function, and wherever there's a variable, you're going to fill in whatever's mentioned here. So I always think of it as the first one is like the skeleton. Okay, so that's the framework for the problem. The next one are the guts. You go ahead and you fill in the skeleton. Okay, let's go ahead and look at this. If f of x is x plus 2 and g of x is 4 minus x squared, if I want f composed with g, that means f is the skeleton. So where x is, I'm going to fill in something else plus 2. And that's what I mean by kind of like the skeleton. This is the framework. But now where the variable is, I take the g function and I fill that in. So it's 4 minus x squared. There's nothing to distribute. There's no exponents. So I can simply drop the parentheses, combine like terms. So negative x squared, 4 plus 2 is 6. Okay, now the next one, g is mentioned first. This is g composed with f. So g, this is the skeleton. Where the x is, that's where I'm going to fill in the f, which is x plus 2. Now this time it's a little bit more work because I have an exponent of 2 on a binomial. So it's 4 minus, this means I have x plus 2 two times. So again, it's 4 minus, I FOIL these. X times x is x squared. Now here we go, outside, x times 2 is 2x. Inside is also 2x. 2x plus 2x makes 4x. 2 times 2 is 4. Now what we need to be careful of is we are subtracting this. So this minus sign needs to go to each term. 4 minus x squared minus 4x minus 4. Now when I go to combine like terms, positive 4, negative 4 cancels. Negative x squared minus 4x, and you're done. Now here's a cool thing that can happen. You can actually compose a function with itself. So what that means, let's go ahead and take the first thing that's mentioned. This is the skeleton. So it's 4 minus something to the power of 2. Now in the place of that variable where x was, where I left that space, we're going to fill in the g function, which is 4 minus x squared. So I actually put the g function into the g function. So cool. So let's go ahead. This one's a little bit longer again. This power of 2 goes on a binomial. So 4 minus x squared. I have that 2 times. Now if I FOIL that, 4 times 4 is 16. 4 times a negative x squared is negative 4x squared. Negative x squared times 4 is a negative 4x squared. Negative times a negative is a positive. X squared times x squared is x to the power of 4. Now again, what we're doing here is subtracting this. So that negative needs to go to every term. 4 minus 16, negative times a negative makes that a positive 4x squared. Negative times a negative makes that a positive 4x squared. Negative times a positive makes that a negative x to the power of 4. Now what I need to do, guys, is go ahead and combine like terms, put it in standard form. The highest exponent is a 4, so it's negative x to the power of 4. 4x squared plus 4x squared makes 8x squared. 4 minus 16 is negative 12. There is your new function. Okay, so this whole section, remember the beginning of 3.5? We took two functions and we created a new one by adding, subtracting, multiplying, or dividing. We're still doing the same idea in a sense that we're taking two functions and we're performing some kind of operation. In this part of the section, we're doing a composition, but your solution is a new function. Okay, now just like at the beginning, notice here, all of a sudden they put a 2 here. What that means is we perform this composition, then we go back and change the variable to a 2, so we'll have a numerical solution as well. Okay, notice it says f composed with g. So f is the outside. So I always go ahead and rewrite everything from the skeleton function. Okay, so it's the square root. I'm filling something in for x plus 4. What are we filling in? The g function, which is x squared. Done. There's your new function. Now there's a 2 here. So I go ahead and I have to replace the x with a 2. 2 squared is 4. 4 plus 4 is 8. Now 8 is not a perfect square root. So we have to go back to Algebra 2 where you learn how to simplify radicals. 8 is 2 times 4. 4 is 2 times 2. If I can cross off 2 with the same thing, that gets to go on the outside. This 2 could not be crossed off, so it's on the inside. So you would have two solutions. Your first one is the new function. What does it look like if you put g of x into f of x? Your second solution is what numerical value do you get if you replace x with a 2? Okay, here's the next one. Again, we're following the directions. F composed with g, and then we'll change the x to a 2. So the f is the outside, but g fills into where the x was. Notice I have a square and a square root. Square on a square root cancel. So my new function is simply x plus 1. Now you take that new function and you replace the x with a 2. 2 plus 1 is 3. Okay, let's go ahead and look at the second set of notes. Same idea. What they did was said f composed with g, then fill in a 2. Okay, so we're going to keep practicing. This time we're dealing with an absolute value. So it's the absolute value of x, but we're replacing x with the g function, which is x plus 6. So that's your new function. You filled g into f of x where the variable was. Now I go ahead and change the x to a 2. 2 plus 6 is 8. The absolute value, remember that means how far is 8 away from 0 on a number line? Well, 8 is 8 units away from 0 on a number line. Okay, last one like this. I am taking the f function, it's 1 over, but instead of x, I'm replacing it with g, x plus 3. There's your new function. Because I have a domain restriction, you do have to state it. Your domain x can never equal negative 3. Because if x equals negative 3, then you'd be dividing by 0, and this thing actually would not exist. It would be undefined. So in order to have a defined function, x cannot be a negative 3. Now we take this and we replace x with a 2. So it's 1 over 2 plus 3. 2 plus 3 is 5. So you guys, those are compositions. Now here's a skill. As you get into calculus, it's really, really helpful to be able to do this in reverse, okay? So what happens is they give you a composition function. They want you to figure out what was the skeleton and what were the guts. So be able to basically dissect, or they call it decomposing, okay? So you take it apart. So when you're doing your f of x, what you want to do is look for the basics. Like, do you have a fraction? Do you have a square root? Do you have an exponent? The basic setup, that's what f of x is. So here, notice we have a power of 2. So f of x would be x squared. But what actually has that power of 2? That's g of x. That's what you filled in. It's 2x plus 1. So in order to create this, you fill 2x plus 1 in for the x, so it would have the power of 2. You're done. Okay, the next one. The skeleton is the basic shape or what's going on. Here it's a cubic root. So a cubic root, that's the skeleton. But instead of x, they filled in the guts, x squared minus 4. So x squared minus 4 went into x, and that's how you got that. The next one, f of x is the basic shape, okay? In this case, notice that we do have a fraction. So it's 1 over x. But it's not just an x on the bottom. The guts were an x plus 2. They took x plus 2 and filled it in for x. So these are called decompositions. You're just going backwards. They give you the composition. You have to figure out what was the skeleton and what were the guts. Last question of the day, guys, and there is no assignment for this because we are going right into like a mini quiz. A lot of it's multiple choice, but it's just on section 3.5. Okay. The number n of bacteria in refrigerated food is given by this, okay? And the domain, meaning this function works if T, which is the temperature of the food in Celsius, this is accurate when the temperature is anything in between and including 2 and 14 degrees Celsius. This will tell you the number of bacteria that would be in refrigerated food based off of the temperature of the food. When the food is removed from refrigeration, so let's say you're doing a holiday potluck and you put the food on the counter, the temperature of the food is given by this function, and it is accurate for 0 up to and including 3 hours, okay, because T is time in hours. Find this composition, okay, so we're taking N, that's the first one. So it's 20, wherever you have a variable, we are filling in a different function. So again, it's that whole composition thing. I just took out the T's. This is the skeleton though. The framework stays. Where I have variables, I need to fill in this function. So it's 4t plus 2. 4t plus 2. Now what I need to do is go ahead and expand this. So this is going to be a little bit of work, but we got this. So it's 20 times 4t plus 2 two times, minus 80 times 4t plus 2 plus 500. So now I'm going to go ahead and FOIL. 4t times 4t is 16t squared. Outside, 4t times 2 is 8t. Inside, 2 times 4t is 8t. Last, 2 times 2 is 4. Okay, so far all I've done were the exponents. Okay, I'm doing the whole order of operations. The exponent means I had that group twice and I expanded it. Okay, order of operations, you multiply before you add or subtract. So I need to go ahead and distribute the 20 in here. If I take 20 times 16, I get 320. So 320t squared plus 20 times 8 is 160t. 20 times 8 is 160, that's connected to a t. 20 times 4 is 80. Now I go ahead and I distribute negative 80. Negative 80 times 4 is negative 320t. Negative 80 times 2 is negative 160. And don't forget we have that plus 500 at the end. Now if I combine like terms, 320t squared. This has a t, this has a t, and this has a t. So 160 plus 160 minus 320 is 0. Cancels, cancels, cancels. 80 minus 160 plus 500. This is a positive 420. Here is your new function. What this tells you the number of bacteria. Okay, so whatever's on the outside, that's what you're trying to find. Okay, so this, what are we trying to find? N, number of bacteria, based off of our variable is time. So number of bacteria based on time rather than temperature. Okay, so if I go ahead and I look at B, find the time, so we're solving for T, when the bacteria count reaches 2,000. So let's say like that's the big no-no. You should not eat food once the bacteria count reaches 2,000. So you want to know how long can I take the food out of the refrigerator and have it still good. Okay, so I go ahead and minus 420. So 320t squared, 2,000 minus 420 is 1,580. Divide both sides by 320. And I have t squared equals 4.9375. To cancel a power of 2, you'd simply take the square root. I cannot include a negative because t stands for time that the food is outside of the refrigerator. You can't have a negative time, so I'm only doing the positive. 4.9375. It is approximately 2.22 hours. So if you are at a potluck and you have a food that needs to be refrigerated, you can really only leave it out safely for about 2 hours. Otherwise, that bacteria count reaches 2,000 and you probably shouldn't eat it. You guys, we just finished 3.5. I hope you enjoyed compositions of functions, and I'll talk to you in a little bit.